This will be the exercise or the video walkthrough for Lab 6. Lab 6 is subnetting 1. Students will practice basic Class C subnetting. So I will use different IP addresses than our homework. 192.168.0/24. So this is what I give you, is an IP address with a prefix. It is not subnetted, designated by the /24, which means I give you all 256 addresses to use within this subnet. We identify the class of this address. We know by the 192 it's a Class C. Let's say we need to accommodate, we'll start this one kind of easy. We need to accommodate 125 hosts per subnet. So let's start to figure this out. How many bits are we borrowing? So we need to accommodate 125 hosts. Once again, I'll show you a trick to use. If you draw out your 8 lines, four, 2, and 1. We can kind of get an idea of the prefixes also. So a little trick that also helps with those prefixes would be a /25, a /26, a /27, /28, /29, /30, and 31 we won't do, and 32 we will not do. So as we look at this, we can say, okay, we need 25 hosts in a 128. If we were to move over to a /25, the host is actually also represented by the value we see in our dashes. So we know that we have 128 hosts within a /25, 64 hosts per subnet in a /26, 32 in a /27, 16 in a 28, 8 in a 29, and 4 in a 30. So for this one, we know we need 125. So we'll borrow 1, and that'll leave 7 left over. We know this because there's 8 bits to a byte, and we only borrow 1. How many bits are remaining? So our remaining bits would be the following 8. Or I'm sorry, the following 7. What is the number of hosts per subnet? We figured that out through this bottom number here. We have 128 hosts per subnet. Excluding the broadcast and the network address, we have 126 hosts per subnet. And I believe that answers another question. Yeah, usable hosts per subnet. We have 126. That leaves us usable. That'll leave us 1 extra for growth. And then what is the subnet mask? So having our 8 dotted lines laid out, we will also be able to figure out the subnet mask this way. So for our class C, the subnet mask should be 255.255.255. Sorry for that 2 there. We know for original class C it's 0, but we're borrowing bits. So looking at the our 8 lines, we know that our subnet mask is going to change to a 128. So our new subnet mask is going to be 255.255.255.128 because we borrowed the bit in our first number, which is marked with the green, and then it's pointed to with the drop-down blue arrow. And that's going to be our new subnet mask for both of these networks. Now we only have 2 subnets with this one because we only have 128 can only be, if we double this, it'd be 256, which would be our values from 0 to 255. Now let's see, for the second part, or I should say for more, insert blank page. So for the second part, we do subnet 0 and subnet 1, because we know we only have 2 subnets with A/25. Our first address is going to be 192.168.2.0.2.0. The second one's going to be 192.168.2.128. So that's going to be the start of the first and second one. We'll know we'll have a range, and I'll rewrite this on a third slide. The broadcast I can deduce from looking at this one here, but the broadcast is going to be .127. The range is going to be 1 to 126. The range will be 129 to, and here's another way to cheat. I know this is 255 because that's the last value I can have. So this is going to be 254. So quickly I worked through these both, the subnet for the network address, the available host range, and the broadcast address. I'll do another slide to show you how I deduce this, a little bit more slower. But I can see that I know the network address is always going to be my first available address, which is a 0. I know that I have 128 available, not usable, available IP addresses. So I knew to go down to here and to start my next subnet. Then I started to work it backwards. I knew my max I could ever go was 255, and then one less than this one here would be my broadcast for my previous subnet, and then I just filled in the areas. One more than 128 is 129. One less than 255 is 254. The same up here. One more than 0 is 1. One less than 127 is 126, and that's how I was able to figure out my range. Once again, I think it's probably easiest if we, until you get the hang of it, the absolute hang of it, is to just, I find it always easier, and this example is not pertaining to anything. We'll say subnet 1, 0, 1, 2, 3. So we have 4 subnets. Remember, 0 is always the first subnet. If you do see a 0, make sure that you're identifying that as the very first subnet within a network. say we did a /26. So I know the first IP is going to be 0 for the network address. The second network address is going to be, what did I say, 26, so it'd be a 32. 25, 64, it'd be 64. I'm sorry, messed up. So 26 would be a .64, then 64 plus 64, 128. And for the fourth network, 192. And then I start to backfill. 64 minus 1 for the broadcast will give me 63 for this one. Minus 1 from subnet 2 would be a .27 or 127. 1 less than 92 for the next one would be 191. And then my absolute last can only be 255. So there I quickly filled out the first and last of every subnet, and now it's time to go back and simply fill them in. 1, 2, 62, 65, because it's one more than 64. Now I need one less than 127, 126, 128, so 129, one less, 190, 192, 193, 254. Now when I'm grading your material, the first things I look at is if this row is even, this row is odd, this row is even, and then this last row is odd. That's the very first thing I look for, and that's what you can do to spot check yourself, is to make sure that you're following this basic format, even, odd, even, odd. From there, it should be intervals of only 128, 64, 32, 16, etc. As we work down the values of our dotted lines we see here, as we see in the bottom here, or the middle of the screen, it should be only those values that you're actually working with that I see in the very far left row, and then always one less in the very far right row, and then in the middle it should be a range only given between the correct network address and the correct broadcast address. So your range should only be within those two numbers. If not, I usually mark it wrong. I think that's good. We did a good job covering this one.